uh, and
Yes.
one small topic is there, DME, DME, R now. Uh, just I want being to participants, just they should be interactive. Uh, Anybody can tell something on what is R now? People working in NAV site or NAV facility.
So this is performance-based navigation.
It's a part. It's one component of performance-based navigation. Okay. Uh, this R now is called as a area navigation. Okay. So first of all, if I just most probably only half an hour session or so. So anybody can tell what is navigation. So far we have studied about the VOR, DME and all, and in subsequently we'll be studying about ILS also. So what is navigation? Anybody can tell? Anybody? Be interactive. Don't be silent. Anything you can say. No idea. Yes. No. This. That. Something like that you can say. What is navigation? Ah, yeah. In simple terms. Am I audible to others? Hello.
Audible, sir.
Okay, but people should try to say something. You know. What is that?
Sir, navigation is the art of determining the position of an aircraft over Earth's
Okay.
surface and
Okay.
guiding from one place to another place.
Okay. Anything can be added with that.
Providing guidance, can say.
It provides guidance of to the particular aircraft for flying from one place to other place with the help of radio navigations.
Okay. Fine. So it's that is art of flying from one place to another. Okay, providing guidance by ground based equipment, or it can be any facility or any system based on space is okay, like GNSS, GPS, जो भी हो, whatever it may be. Number one. Number two is from ground something is expected. Okay, to regulate the traffic. For that, air traffic services is there. Number three, planning your flight. That also is must. So anybody be prior to flying from one place to another, they have to, in aviation, I'm telling about in aviation, they have to plan their flight. How do they fly? From where they fly? Source, destination, everything has to be put in flight plan. Based on that, only services will be provided to fly from one place to another, A to B. If so, then while flying from A to B, what are all the navigation facility the aircraft will use? That also it matters. Then only they can fly safely from one place to another. Safety is that is important, most important. Okay, without safety, safety can at no time safety can be compromised. Safety is must. Okay, okay. In DME, how using DME, what aircraft is going to get, or what pilot is going to get? Everybody we know the distance, right? What distance it is? Hello, be interactive here. I think participant has
He will be getting slant distance from the
slant
station.
slant distance, right? Okay, 1 minute. Okay, slant distance. Okay, for VOR, from VOR, we
Magnetic
are
bearing.
magnetic bearing of the aircraft. So we're using magnetic bearing and the slant distance. Yes, one can comfortably fly to any point in the space. Okay, so long we were using. Now also it is being used. In future also it will be used. But this portion R now is slightly different concept by itself. Okay, what this is called area navigation. What does it mean? How we can move about on that? You see, this is the one which gives about the conventional navigation and RNAV. You see, are you able to see by mouse movement? Are you able to see my track my mouse movement?
Yes, sir.
Yes,
Okay.
sir.
From you can see if, any aircraft is flying from WR to man. Earlier it used to fly something like this: WR to THE, NIF, FRK, MAN. This is conventional navigation. This can be anything. What is this facility? The symbol
DVOR, sir.
VOR. It's not only VOR, that is called as a TACAN. VOR and
Yes.
DME, tactical air navigation. Okay, VOR and DME. So what anybody who is going to fly aircraft is going to fly, he will get the bearing as well as the distance from one facility to other facility. So can that aircraft can fly in segments A, B, C, D, E. Okay, this was good to some extent. Nowadays, this is not being used. Rather, it's nobody is flying this way. Instead, they fly this way. This is called as an area navigation. What is the difference you will find between these two? You can find from WR to man if you want to fly, he will fly directly. Okay, he will not fly towards THE or BAF, whatever it may be, he will fly directly. But however, he will use the facility THE and BAF. By this, what is achieved? By this, by area navigation, what is achieved mainly?
Time saving and fuel saving.
Fuel
Saving
saving.
the fuel.
Time saving, right? Fuel saving, number two. Number three is carbon emission. Carbon emission is, that is, it needs to be reduced drastically by anybody who is going to fly. Carbon emission. Okay, so time saving, fuel saving, thereby resulting in carbon emission. So slowly you can find almost all our aircraft, mostly in en route airspace, they will fly this way only using RNAV, area navigation. But instead they will be using the ground based navigational equipments facilities, or global positioning system, GPS, or we can say in short, in generic term, it is GNSS, global navigation system. Okay, so this is the way in which it is defined. Conventional routes you can find at the first left one, ground based, like that zigzag it goes, but ultimately you will find that is having only limited flexibility. Whereas in RNAV routes, you see the routes are defined. This symbol, this symbol represents what? Waypoints. You can see waypoints. So it will fly from one waypoint 1 to waypoint 2, waypoint 3, waypoint 4, ultimately reach the destination. So by that, what is the increased efficiency? So this is RNAV routes. This is RNP. One more, still ahead. Again waypoints, but you see the paths are curved. Paths are curved. So it is highly optimized. So you can see migration from conventional routes to RNAV routes and RNP routes. That is the latest. Most of the routes you can find RNP routes also, RNAV routes also. Okay, at least for the participants, slightly deviates from our technical this thing, because having given in attachments, we should know slightly about other things also, like RNAV, RNP and all, when we use navigation aids, study navigation aids. Okay, so first it was having only limited flexibility, and migrating to RNAV, increased efficiency, highly optimized. By this, again, what we achieve? Again, as we said earlier, reduce the time,
Reduce fuel saving.
fuel fuel saving, carbon emission. Other than that, anything is there? Anything is there other than that? Can you guess? Anybody can guess?
The deviation from the desired path is reduced.
No, 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 not that way. This is
So
desired path.
optimize use of airspace.
Optimize use of airspace. What does it mean? What does it mean? Optimized use of airspace. What does it mean then?
capacity enhancement.
Yeah, capacity. That is much earlier. See, earlier days, some 20 or 30 years before, traffic was not that much. But nowadays, you can find traffic scenario as quadrupled or five times it has increased. Anywhere in most of their spaces around the in and around the globe. If you see, mostly in US or Middle East or Indian airspace or Southeast Asia, you can find the high traffic density is there. So still with conventional routes, one cannot fly. Naturally, you need to have some sort of other flexibility. So that's why this that is RNP routes were designed. This is mainly based on airspace designing. It's nothing to doing with CNS or technical this thing. This is airspace design mainly with resides with ATM counterpart, right? But for us, we have migrated slowly using this ground-based equipment slowly from conventional to RNAV routes to RNP routes. Migration has taken place. Okay. If you see from our AIM India portal, you can find lot of RNAV routes, RNP routes are there available in Indian airspace. Okay. You can just check it up. So this is, you can again, you see, again, one should know about the phases of flight. Starting from departure, initially it climbs, cruise phase, descent phase, initial approach, final approach, landing, missed approach. This is the way in which phases of flight are divided. Got it? Now, we are DME. We are DME. Which phase they will be using? Almost all the phases we are DME will be used. Starting from departure phase, initial climb, cruise, descent, initial approach, final approach, landing, everywhere we are DME is used. And in likewise, ILS, it is used during landing phase. Okay. One should know what are all the different phases, because once you want to know about R now, definitely different phases of flight one should know. This is just only a brief introduction. You need not worry about that. Just a brief introduction. You can build upon at later time. Okay, you can see. So this is the departure phase, en route, approach, landing. You can see how an application of RNAV RN specification to ATS route and instrument procedure is defined. You see, starting from departure, you can find this is RNP1, RNAV 2. This is a different segment. This is departure phase. This is en route phase. This is oceanic region. If it is going to fly over ocean, Bay of Bengal or Arabian Sea, Jobiho, whatever it may be, then the specification is something different. RNP4, RNAV1, RNP approach. What this 241 defines? Can anybody tell? Last in viewer class, just we were just seeing this 241. Suppose you take R now. 2, what does it define?
Sir, separation between the aircrafts in terms of the distance, sir.
Separation, you can say, or otherwise, one thing I will show you this one. This is the difference between what R now. This is R and P. You see, this is R now 1 mile. You see the lateral distance maximum, it's 1 mile. Lateral distance here also it is 1 mile plus still one more mile it can go. Why this arises? Now my question is, why this arises? Can anybody say? TSC. TSC is one term. This is called as a total system error. Total system error. Okay. Can anybody tell what is a total system error or what is error? Why is this space defined? This space, this is the path, but this is the extra buffer space. Why is it defined?
Sir, every system is not 100% guidance which is providing. It may have some errors, and hence that navigation signal may also provide a bend to the aircraft, so it may shift from the accurate path which it has to follow.
Exactly right. You are absolutely right. You see, the system error is going to be there. System error in DME, is there any system error? In VR, is there any system error? In DME
Yes,
is
sir. For DME 340 meters, something plus
yeah,
minus 1.25%.
yeah, yeah. That's why the Annex 10 we have studied tech specification. Any facility is going to provide some signal, navigation signal, which will be used by the aircraft. But unfortunately, the generation, transmission, propagation, terrain, lot many things comes into picture, which is not in our control. Okay, so that added to that, there will be a measurement error also. Measurement error also. So while airspace is being designed, this buffer space is must. Based on that only they divide. So RNAV one is this. They sell about the 1 mile. You see, total system error can be between either side 1 mile. RNP again 1 mile added to the 1 mile either side of this it is defined. So this is the difference between RNAV and RNP. Okay, this is because of there is going to be error in measurement. Number one, error in the ground equipment or error in the onboard equipment. Anywhere it can be. Anywhere it can be. So that has been taken care. Based on that only airspace is defined. But we think that actually this is the position of the aircraft. But the position of the aircraft may not be here. Maybe here somewhere after some time, in maybe here, anywhere it can be. That is why they have told here 95% of the flight time this will be between this band. So whether it is for RNAV1 or RNP1, the aircraft will be 95% of the flight time will be within this band. Okay, that is based on that only specification, navigation specification is defined. These are all everything will is available in performance based navigation manual doc 9613. Anybody interested? If you want, you can just go through. Okay, that is clearly given in doc 9613. Though it doesn't we don't require that one, but still out of interest in future it will be something like this only. So naturally you have to learn, you can read. Okay, are you getting me? Others, please, anybody?
Yes, sir,
Yes, sir.
getting you.
Sir.
Okay, so you can see these are all the different phases, and the next this thing you can find in different phases what are all the navigational specifications followed or used in airspace. So departure phase it is RNP1, it is slightly stringent, and en route phase it is RNAV2, slightly bigger. Oceanic it is slightly more RNP4 and R maximum, and likewise arrival 1 RNP approach is still stringent. This is the way airspace is defined. Okay, so you can find this airspace consists of lot of airways and consists with a lot of waypoints. Based on that only any flight flies through the waypoint airspace from departure to arrival. Okay, you can see just for an example a R now 5, how is it defined? Accuracy plus or 5 miles, R now 5, so plus or minus 5 miles for 95% of the flight time it is. Integrity, anybody can remember at this time what is integrity?
Sir, integrity means faithfulness, means how much time it will give the same reading again and again.
Integrity, okay, integrity, the faithfulness,
Repeated
it is
performance means repeated performance.
repeated performance. Added to that,
Faithful.
anything? It doesn't stop with that integrity. Faithfulness, okay. If it I miss faithfulness, what happens? If my equipment is not faithful enough, what happens?
Sir, it should not provide misguiding information. It should
Mm.
stop.
That's what we have just read in VOR. During VOR, just we were going through all those things. You see this one. You see no equipment should give the misleading information. As far as everything is fine, normal operation is there, it's fine, good. My system is giving false alarm, yes, good. But my system never should give misleading information. That is why integrity. If integrity is there, integrity risk also is going to be there. So what are all the parameters are available? You see, it is matched with the accuracy and failure detection. So accuracy, definitely Annex 10 is defining what the accuracy a DME should have, a DVR should have. And a failure detection is taken care by the monitors and control circuit. So this one is very much hazardous. Okay, that's why in our DVR class we have seen integrity and continuity of service. No time misleading information should be given. Normal operation fine, alarm operation is fine, my system shut down. But even after in alarm my system is not shutting down means that is dangerous. That should never be allowed. Okay, so that's what we were studying in BOR. Now integrity. This is what just we were seeing integrity. So 10 pi, see, in per hour only this much can be for a RNAV 5. If RNAV 5 can be used by which facility? Can be provided by either GNSS, Global Navigation System, or it can be given by a DME and a DME. RNAV means there will be two DME facilities. It's not only a single DME facility and aircraft fly. If we speak of RNAV DME means two DME facilities will be adjacent DME facilities will be used for flying. R DME and IRU. IRU is initial reference unit. Suppose GNSS fails, airborne equipment can use a DME. If DME also is fails, it can use IRU, initial reference unit, which is within the aircraft itself. Okay. So how save matlab, with a lot of safety everything is designed. GNSS is the primary source for providing navigation signal. Secondary is a DME and with IRU. But this these are all the facilities, but RNAV computer is nothing but a FMS which is available on board. These are all the devices given to the pilot. CDU is the control unit, navigation display. HSI and CDI you be knowing. What is HSI or CDI? What is HSI? Hello? Why you are silent all? What is HSI? Are you getting me? Hello?
Getting, sir, getting.
Okay, what is HSI here? You may not be knowing about ND or CDU or R now, but HSI and CDI you should be knowing. We have studied CDI. What is CDI?
CDI is cross deviation
Cross deviation indicator or course deviation indicator. HSI is horizontal situation indicator. These are all the basic display devices used by pilot when he is using VOR or ILS, HSI or CDI. But this ND and CDU now all latest onboard flights have. RNAV computer is nothing but FMS, flight management system computer, with a navigation display and a CDU. Okay, and signal in space also one of the important category. It also has error, maybe due to multipath effect or interference or terrain or obstacles, whatever it may be. Okay, FTE, PDE. FTE is a flight technical error or path distribution error. You can see this also plays an important role. A long track error within 5 miles, RNAV 5 for 5 miles, for RNAV 2 it is 2 miles. So 95% of the time the error should be within 5 miles. Okay, alerting is not there. Alerting is not there. Okay, alerting will be there if it is going to be RNP. That is the difference between the RNP and RNAV. If alerting is not there, then mostly it is RNAV. If alerting is there, it is RNP. Alerting means alert will be given to the pilot. Yes, this my navigation onboard navigation system is not functioning properly. An alert will be given to the pilot. Pilot immediately what he has to do is he should use some other facility, either DME, and accordingly he should tell to the air traffic services also, ATC also. I have lost my GPS navigation signal. My system will not be so accurate. So I am flying using DME, whatever their procedure says. So this alerting function will not be there if it is going to be RNAV, whereas alerting will be there if it is going to be RNP. Okay, this is the difference. You see, this is the navigation specification, RNAV, RNAV10. These are all the different. I have taken, this is bit old. Nowadays, there may be some other development. You see, GNSS can support all the flight phases. Flight phases are, do you remember this one? From departure to landing, GNSS supports navigation. It provides navigation supports, or it can be used as a navigation source. Whereas IRU, initial reference unit, can be used only for RNAV10 and RNAV5. Only this portion. In other portions and all, initial navigation system cannot be used. And DME can be used for RNAV5, RNAV2 and 1, like this use. VRDME can be used, it will be used only for RNAV5. Okay, these are all the different navigation specification, wherein these are all the different navigation infrastructure can be used during flying. Okay, are you, it may be bit new, so you may not be able to get, but still you can grasp, because we know what is DME, what is VOR, what is GNSS, we know, at least you can grasp. Okay. Okay, now coming to this portion, DME to DME RNAV portion, increasing use of DME to support RNAV. Earlier we have seen in conventional navigation this thing, only aircraft used to fly in segments towards one VOR DME, next VOR DME, like third VOR DME, like that it goes. But nowadays it doesn't fly likewise. It takes a very shorter path. So it uses a DME and does not impose any additional technical requirement on the DME system. But simply by using RNAV, you need not upgrade your DME and all. Whatever DME infrastructure is there, that is more than sufficient to design RNAV routes. Number 3, DME to DME positioning is based on the aircraft RNAV system that uses a triangulation method for position determination from multiple DME ranges. You see, multiple DME ranges. In RNAV, DME uses 2 DME facilities for position determination. Other than that, one in aircraft, one database also, navigation database also is available. This results accuracy of the position solution depends on the range to the DME and the relative geometry. This is also a must. Accuracy of the position solution depends on the range. If it is too far from the facility, yes, FMS will not use that one. It will be automatic mostly. And relative geometry between the DMEs, so 2 DMEs, that also plays a bigger role, relative geometry. So this is the basis in which an aircraft fly using DME RNAV route. Okay, RNAV, to fly any RNAV or RNP route, that flight should be certified enough. Not all flights can fly in RNP1. No. Number 1. Number 2 is that pilots need to be certified. Okay, lot many things are there. It's not only we are just providing DME, any aircraft can fly in different routes. That is not possible at all. Certification is must. Okay. Next one, sufficient number of DME are available and their location provides adequate geometry to meet accuracy requirements. Yes, we are having enough DME infrastructure at the ground, so aircrafts can use DME and DME, both 2 DMEs. For approach and departure procedures, adequate signal strength from DME needs to be available. This is must. That is why we have, as a technical person, we maintain our systems checking all the routine test as per the maintenance schedules. Okay, that we maintain. So definitely this will be there. But provided that we need to take about the care of nearby our surrounding space also, terrain conditions also you should see. That is why sometimes during the annual checks and all, we check our terrain is okay or not, nearby bushes are there, obstructions are there, those things to be cleared off. Next point, DME positions are to be surveyed correctly and published. This normally prior to installation, they do this survey and all. Accordingly, it will be published. Once this is published, that will be put in navigation database, which will be used by the FMS. With co-located viewer facility, the DME position should be separately surveyed and published if the suppression distance exceeds 30 meters. Now, in some cases it may be, and most of the cases it is co-located to DME and within 30 meters only. So DME and viewer position will be same. Okay. So if these are all the points which in attachment they have given for DME, DME are now. Okay. This is the way in which DME will be used. Both two DMEs will be used by any aircraft flying. Earlier, what we have seen, an aircraft will be flying this way, number 2, number 3, and it reaches destination. But nowadays, it doesn't go like that. It goes in the straight path. It uses two DME, DME A and DME B. So this is the range A, range B. It finds the position. It flies at each and every point. It checks, FMS checks, and when it flies, it takes from this DME, DME. When it moves apart, no more this DME will be used. This DME is being used along with this DME. Likewise, only an aircraft fly through the different waypoints and using DME infrastructure, DME A, DME B, like DME B and DME C. So that is called as a DME, DME RNAV. This is RNAV route. RNAV route. It can be RNAV 5, RNAV 2, RNAV 10. That depends upon the airspace. And as we earlier seen, the accuracy of this is must. DME equipment is must. Okay. It's not only for DME, for VR, localizer, ILS, whatever it may be. Accuracy is to be maintained. DME, how it functions? Onboard FMS is fed with input from multiple sensors, calculates a navigation solution. Navigation solution is nothing but a position determination that is calculated by flight management system, in fact, flight management computer. And accuracy depends on the geometry of the DME with respect to the aircraft, signal in space, because that's what we have seen. Signal in space can be suffer from multipath errors, from terrain effects, from obstructions, from bushes, whatever it may be. So that is not in our control. So accuracy depends upon all these factors. Okay. So this is the, you see in this example, two DMEs are there, DME A and DME B. Here you can see some two bands. Actually, this is the true line location of from DME A measured line. You see what is this? This is true line of DME. From this DME, an aircraft is going flying this way. That is the true line, but measured by the intra system, airborne system. Interrogator is tells something like this. So what is this? This is nothing but the error. Error due to the measurement or due to the facility, ground based facility, or due to the airborne equipment, whatever it may be, anything can be taken into account. This error. Likewise, from DME B, you can see this is the error, uncertainty area. Based on that, this from DME A and DME B signals are received and fed to the FMS. FMS will find a solution and it gives the position. This is what happens in DME, DME RNAV principle. Two DMEs will be used, uncertain area will be, that is measurement will be done, and position information will be given to the pilot. Okay, pilot will know whether my airborne system is functioning properly or not. Okay. And when using DME, DME, this is called as another area of DME positioning. Whatever the area in green color, that can be used when two DMEs are used. This portion, central portion, and this portion, no DME, those DME cannot be used because the accuracy is lost. So accuracy in this zone is fine. In this zone is fine, but here accuracy is lost. Okay, that's what this tells us. When DME, DME, both two DMEs are used in R now, an aircraft flying in this zone, definitely accuracy is maintained. Okay. So what is that called? Error of DME, DME positioning means this angle between the two DMEs. Okay, sorry, angle between the aircraft. I will show you the next this thing. It should be between 30 and 150 degrees. Okay, sorry, I could not get. I will. So this is called as the angle subtended by the aircraft from DME. It should be greater than 30 degrees and less than 150 degrees. So that is nothing but the angle of constant. Sorry, these are all the constant line zone. Okay, if the aircraft is within this, yes, a DME can be perfectly used. If accuracy is maintained, fine. If accuracy is lost, what has to be done? It should be alerted. That alert will be something like this. This is in flight deck. These are all instrument in the flight deck. This is primary flight instrument. This is the navigation display. You can see here one display is there. Required navigation performance to fly in this airspace is RNP2 airspace, but ANP is actual navigation performance. That is the measurement done by FMS. It can be taken care by measurement can be taken care made by two DMEs or two from GNSS or VOR-DME or IRS, whatever it may be. So it tells that actual navigation performance is 0.05 miles, whereas the airspace or RNP route is 2 miles. It is well within this thing. So that's why this is the indication to pilot. Yes, my system is functioning normal. I can comfortably fly in this route. So if it is going to be RNP5 route means RNP5 ANP, whatever measurement is done, like that it goes. So in navigation display, then alert will be there. This will be used by the pilot. Okay. This is what in DME positioning is done. Anything you want to ask, it can be anything here. Silly questions also, no problem at all. Anybody, anything, please, you
Sir,
can.
that angle AB is the angle between aircraft and DME. That
One minute. I don't have exactly angle between the
alpha AB you have shown na in slide between
one.
30 and 150.
Okay, okay. Can I just I will refer to one more this thing. I will tell you. Can you wait for 5 minutes?
Okay, sir, no problem.
Anything, any other questions you can put on, no problem at all. Any other? Yes, people are silent. Please,
Sir,
you can.
uh, sir, in RNAV routes which we are seeing here, they are direct straight path. They are being followed for the waypoints connecting one waypoint to other.
Correct, correct, correct.
How, sir, RNP is providing curved path, sir?
That is there again. There is some ATS procedures are there. Fly by waypoint, fly through waypoint. Lot many things are there. Based on that only, matlab it is designed. Okay. So what
Okay,
happens
sir.
is when aircraft flies towards an VOR means he will fly over at VOR, then he will take a turn like that. It goes. Then he meets the airway. In RNP, he need not fly over, or he can take a curved path. He can just meet the next airway. Actually, this aircraft flies in segments only between waypoints to waypoints. Waypoints to waypoints connection is nothing but segments only. Okay. Suppose this
Okay.
waypoint is fly means what he will do is aircraft flies over this. He will go. He will take a turn and he will meet again this airway. In fly this thing curved path, he will not go over it. He will take a turn here and he will join the airway. So like that only he will go. That is nothing but an airspace design. That one. Okay.
Sir, for them, procedures must also be designed, sir.
Yeah, yeah, that's what we have seen. Just only R now, but procedures are there for that. It's not that simply they have their own
Yes,
procedures.
sir. Yes, sir. Thank you, sir.
This please just uh, bear with me for 2 or 5 minutes. I will just show you. Any other thing you can, if you want to ask, you can please. Other, it's not only Pankaj, somebody else also. Yes, Anybody else?
Sir, actually, this is a very a
No,
new
but
topic for many of the
many of the, but
candidates. So,
okay, that's fine.
at,
It's, yeah, that's what I told
so
you,
for
na.
that reason only, sir, I just requested you to kindly
No, no,
guide us on this topic so
correct,
that
correct. This is a new
everybody can
thing
be
only.
benefited.
This is new only. That's why people may find it difficult. But still, now it is the time for others to just learn this also subject. It's not that only I'll be sticking to technical this thing only, the DME only, some VR or ILS, nothing like that. Your generation, slowly, I think you should learn other things also, right? 1 minute. Are you getting my screen? Hello?
Getting, sir, getting.
Getting, na?
Hmm.
Lot many things are there here. Just I will try to show. Okay, this is the one. You see, ground-based DME, how it finds, calculates position lat long using distance from 2 DME. Lat long, it can be lat long or Cartesian coordinates, whatever it may be. That depends. Required data is V or DME position. Okay. The closer the two station are to one line, the greater the error becomes. Therefore, most appropriate combination of DME is are automatically selected of which relative angle between 30. So between 30 to 150 degrees, yes, these two DMEs can be used. When it goes less than 30 degrees, DME1 and DME2 cannot be used. With the DME2, some other DME3 has to be used, or with the DME1, DME4 has to be used. This way in which this angle is defined. This angle is subtended by the aircraft between these DMEs. It will be between 30 and 150 degrees only. This will be automatically taken care by the FMS. FMS will be automatically tuning to the nearby DMEs. Automatically it will be tuning. Okay, that is why in navigation database it should be updated. Navigation database will be updated in periodically 28-day cycle. Perhaps half people may be knowing what is the 28-day cycle. Anybody? 28-day cycle? Okay, 28-day cycle, anything has to be published. It will be published accordingly. That will be put in database. So that will be put in database on each and every onboard aircraft. Okay, that is why it's a very much critical that the navigation database is very much critical. If that DME is not be used in service or it is decommissioned, means that DME, no, it should not be used by the onboard equipment. Okay, if that DME is decommissioned but it is not published, okay, then the system will be trying on tuning that DME. Okay, that is why the navigation database, every this thing, it will be updated. So each and every aircraft in their fleets, airlines fleet, they will update their navigation database. So when an aircraft is flying between Bombay and Delhi, that navigation database on each and aircraft in which RNP route he can fly, which RNAV route he can fly, if it is going to be a Dornier or it is going to be ATR or it can be 777, everything matters. Okay, based on that only an aircraft is certified to fly from Bombay to Delhi. This is for an example. Not all aircrafts can fly in the same route, nothing like that. Okay, so that's why earlier I have told that flight plan is essential. Then aircraft has to fly. For that, navigation systems will be used, or otherwise navigation infrastructure will be used. That navigation primary source of infrastructure for most of the aircrafts nowadays, most of the aircrafts is GNSS only. That is primary source of navigation. That GPS, using that GPS only, FMS determines the position of the aircraft. The position of the aircraft, whether that position is accurate or not, that is given displayed in the display. That's what we have seen here. This is the one. The aircraft, sorry, pilot can know what is his required navigation performance, what is my onboard equipment's navigation solution. Yes, he knows, he's getting alerted. If it deviates or if accuracy is lost, then he has to accordingly use different set. Secondary source, it can be DME. That's what we have seen, where it can fly. Which you see, if it GNSS is lost, next alternate source is only DME or DME IRU. IRU is not used. VRDME is not used. So that is why you will find primary source of navigation source is GNSS, or it can fly with DME. Okay, this is the basis in which an aircraft fly between A and B using RNAV or RNP routes, whatever it may be, using ground infrastructure or GNSS, anything. Okay, this is the way in which an aircraft flies between A and B. So our job is to see whether our systems are being maintained, means to the specifications, using our usual maintenance schedules, accurate enough, signal strength, everything we measure. Okay, any question further? If you want, you can, or otherwise, Pankaj,
Yes, sir.
anything?
Uh,
This 30 and 150 degrees, are you able to get now?
yes, sir.
Have you seen, or should I show you again? You are
That's
only,
fine, sir.
this is the one slide, 30 and 150. This is the one. Just I was telling you. Okay. So more than
Yes, sir.
less than 30 degrees and more than 150 degrees, the DME, any DME will be excluded from providing navigation solution. Okay. So between these two, in any aircraft flying in this path, yes, it can comfortably use both the DMEs. DME is can use for, and he can fly in this direct path. Like that he can go. Okay. Got
Okay.
it?
Thank you, sir.
Okay. Anything?
Sir, if you
Can we
can
close
throw
now?
some light on,
Which one? Yeah.
sir, this desired to undesired signal ratios also, sir.
Decided to undesigned seminar. Rather, I took in somewhere in the VR class, if I am right. I don't remember.
Yes, sir. Yeah, you have taken, sir.
I don't remember here where I have taken. I am. I
Last
think
time in
correct.
during DVR class only, sir.
This is the decide to undecide this thing. Whether it is for DVR or DME, it is all are the one same. First of all, one should know for any facility, DOC, designated operational coverage is must. One should know whether it is a terminal VR, en route VR, or co-located DME. That designated operational coverage one should know for what purpose the DME is used. Whether it is used as a en route DME or only a terminal DME, that matters. If it is going to be with a glide path, naturally only for that is a landing purpose. If it is going to be a VR, it can be used for en route. So DOC, designated operational coverage. If it is going to be, then two terms keeps in, that is designated operational range and designated operational altitude or height. This must. So this is the example for VR. Same applies for DME also. Only the band is different, right? Anything else matters for
Mm,
VR DME? Anything else matters? Yeah, frequency matters. If frequency matters means other effects are there, na? Terrain effects may be there.
yes,
One is UHF band, another is in VHF band. But whatsoever, okay, multipath effect will creep in if it is going to be in DME. Okay, no problem at all. Here you can see PD. PD is the desired signal. Okay, whereas PU is the undesired signal. If B, if power from B is going to be strong enough, and if it's adjacent to the A, and the frequency is going to be such adjacent channel, so what happens? What happens? Our see our decided the signal to be received is from A, undecided signal from B, that is strong enough. Number one. Number two, and the frequency is such it is next to assigned next to this channel. Okay, what is the spectrum of DME channel? Bandwidth of each DME channel?
1 megahertz.
1 megahertz is the bandwidth of DME channel. Okay, whether our transponder is working normal or not, what do we do for checks? We do checks, na?
Yes, sir. Bandwidth checks.
Bandwidth check, adjacent channel interference check.
Adjacent
Okay,
channel
adjacent, that is
interference.
plus or minus 900 kilohertz, if I am right. I remember.
Yes, sir.
You will be checking plus or minus 150 kilohertz. I don't know. Plus or minus 900 kilohertz. We will be checking whether that 900 kilohertz away from my channel is able to get penetrated into the receiver. That also we check. If that undesired facility is going to be power is going to be high enough, it will get injected. So if it's going to create the interference, so that is the nothing but the undesired to desired signal ratio. If you see, I don't remember, desired to undesired signal, some ratio is to be maintained. If it is for V or something is there, for DME it is something there. Can anybody refer if it is with you now? So that is actually the undesired to desired signal ratio that needs to be checked. So that is why we check the power also. How much power our that is ground based transponder is transmitting. That also is must. It's simply I cannot radiate 2 kilowatt. If my transmitter supports 1.5 kilowatt, I should not radiate 1.5 kilowatt. It's not like that. My specified power only I should transmit. Okay, whether it is for VOR or DME or radar, whatever it may be, this matters because our signal should unnecessarily not interfere with the adjacent facility. So this du by dr needs to be maintained. That is why, sorry, that the ratio is given for DME and VOR also. I think you can refer in DME specification. So what my this thing is interest is designated operational coverage is one should know. What is my range I should know. What is height I should know. If it is going to be a terminal facility, this is the power required. If it is going to be providing en route this thing navigation, yes, my designated DOR is going to be more, elevation also is going to be more, and adjacent channel is going to be a terminal VR is fine. If it is going to be en route VR, naturally that power also needs to be maintained. Based on that only, this adjacent channel frequency is defined by CHQ, CNS planning. Okay, adjacent channel will be at something different, 3 or 4 megahertz away. It depends. Okay, it should not get repeated. This way only they go. So that is a generic model for establishing minimum separation distance. If I am right, this is what it is given in the reference material. I don't, you see here, it is given in this. Sorry, ratio. Okay, what it says ratio. This is for del of for 150 kilohertz. If it is going to be for DME, you can see what should be the ratio. And my transmitter is going to generate 17 or 20 or 30 dB. What will be my ratio? That needs to be checked. Rather, it is checked based on that only the adjacent channels are defined, frequencies are defined, and the power also is defined. Whether it is terminal VR or en route VR, that way it is defined. Okay.
Yes, sir.
Anything else? Anything? I think Pankaj, if I am right, this only they say about the DU by ratio, decide by
Yes, sir.
undecide signal ratio.
Yes.
Okay.
Uh, that is just to avoid the interference from the
Yeah.
adjacent channel.
Correct.
Yes.
Correct. Correct. Adjacent channel. Okay. Yes. Anything else,
Thank you,
sir?
sir. Anyone, please, if you have any query, kindly take this opportunity to ask your doubts and clear it right now.
Okay, you can see in this slide what is the different sensors, what is the error. You can see for CVR the error is going to be more. For DVR it is plus 2.5 degrees. Main factors is multipath. For DME plus or minus zero point 0.2 miles, multipath, loss of replies. INS is very worst. GNSS is very good, plus or minus 20 meter. SIS is signal in space is plus or minus 36 meters. But lot of other factors are there: multipath effect, ionospheric delay, tropospheric delay, ephemeric data, satellite clock. But still it is very much reliable. Okay. So next to that, it is only DME. After that, only VOR. That is why primary source of navigation will be GNSS followed by DME. So in RNAV, they use GNSS first, followed by DME. Okay, and this tells about the system error, how system error plays a role. This is actually the path defined from one waypoint to other waypoint, an aircraft will fly. But path definition, it can be something like that. Okay, definition is nothing but defined in this FMS. Okay, and navigation sensor error, it can be due to DME or due to VOR or due to GNSS, whatever it may be. Aircraft actual position is there, but estimation position. So the estimation position keeps on changing. You see, aircraft has to fly this way, but still it flies this way, and it will be within this buffer that is defined by the RNAV 1 or RNAV 10, RNAV 4, whatever may. That depends upon the airspace. Okay, so basically that depends upon the TSE, total system error. In fact, it is having a navigation system error also inside it. Okay, this is the total system error. Flight technical error, path error are very minimal, but foremost you will find only navigation system error and total system error. Based on that only RNAV, RNP airspaces are defined, added with the ground-based infrastructure or GNSS. Okay, anything? I think this is a very brief session. This should be more than sufficient. Participants who are keen in learning, they can just refer. Lot of manuals are there, lot of materials are there available. Please, you can go through. Participants, are is it okay for you? Just I want some reply here. It's not that simply you are sitting, I am taking, or instructors are taking. It doesn't. You should slightly tell whether how was it. Are you able to get? Are people there, or everybody vanished? Yes, Pankaj.
They are there, sir. Sir,
Okay.
very fruitful session, sir. Still, I hope that everybody must have got a deep in at least whatever is there in our systems. They at least got that points now, and they can refer it for further study, sir.
Yeah, definitely they can refer for lot of manuals are there. Lot of manuals are there. It's my sincere